Uh, there are three different categories of machine learning methods, including supervised learning and unsupervised learning and reinforcement learning. So in this class, we're going to cover these two methods. So supervised learning is sometimes called the classification learning. And in supervised learning, each data actually comes with a class value or target value. And the goal of supervised learning is to predict the class value of input data. That's the goal of supervised learning. Yeah, basically supervised learning is about predicting something. Second method is unsupervised learning. It's sometimes called clustering. And in unsupervised learning, actually data has no class values. And the goal of unsupervised learning is to find the structure that exists in the data. So usually we find the group of similar data in the data in the input data. That's unsupervised learning. The third category is reinforcement learning. We don't cover it here. And reinforcement learning is a little different from supervised learning or unsupervised learning. So in reinforcement learning, suppose you have a goal, and the purpose of reinforcement learning is to find optimal sequence actions to achieve the goal. That's the goal of reinforcement learning. For example, if you play Baduk or Go, the goal of reinforcement learning is to find optimal sequence of actions to achieve the goal. In this case, the goal is to win the game, right? And these days, this reinforcement learning is combined with supervised learning, especially deep learning. So reinforcement learning is combined with deep learning, and it's called deep reinforcement learning. And this is kind of a new direction of the research in machine learning. There are some other machine learning methods like semi-supervised learning. In semi-supervised learning, some data has class values, and some others do not have class values. This is combination of supervised learning plus unsupervised learning. Okay, that's why we call it semi-supervised learning. So in semi-supervised learning, some data comes with class value, and some other data doesn't come with class values. So the goal of semi-supervised learning is how to improve the performance of supervised learning by using unlabeled data. Okay, that's the goal of a semi-supervised learning. Finally, we have another learning method called generative learning or generative model. And the goal of generative model is, so in supervised learning, the goal is to predict something, okay? But the goal of generative learning is actually to generate something. For example, in generative learning, it generates image or movie, or it can generate sound, or it can generate text. Okay. So that's what a generative model is about. The typical example of generative learning algorithm is like a GAN or a variational autoencoder. So these are some typical categories of machine learning methods, and we're going to cover these two methods in this class. So this picture shows the concept of three different machine learning methods. The first one here is supervised learning. Okay, so in supervised learning, as you can see, every data has class value label. So every data here has class value, let's say it's a red dot. And all these data here has class value cross. And the class value of this data is star. Okay, so every data has its own class value, whether it is a red dot or cross or star. So you can use supervised learning or classification learning when every data has class value or label. Okay. So the goal of supervised learning or classification is actually in supervised. The goal is to find a line this. This is called a classifier, or you can say this is classification algorithm. So the goal of learning in this supervised learning is to find best line here. Okay, but most likely, depending on machine learning algorithm, this is not necessarily line. It's actually it's going to be very complex curve, something like that. Okay, not necessarily line. Okay, unless it is linear classifier, most likely your algorithm, your machine learning algorithm classifier it's going to be like a very complex curve. Okay, so anyway. The goal of learning in supervised learning, classification learning, is to find this boundary, whether it's going to be line or whatever, curve or whatever. Okay. So move on here is this picture shows unsupervised learning. So in unsupervised learning, every data has no label, just input data itself. It's no class value, no label. So so in this picture, this data forms group, and this data forms another group, and this data forms groups. So each group here means these data are similar to each other. Okay, again, these data are similar to each other, and again, we have a similar data set here. So the goal of unsupervised learning or clustering is to find groups like this. In this particular case, we find 3 groups of data. Okay, so in each group, the data in one particular group is supposed to be similar. Okay, so again, the goal of clustering, unsupervised learning, is to find group like this in the original data. Okay. Down here, this picture shows the semi-supervised learning. So in semi-supervised learning, actually, it's combination of supervised plus unsupervised learning. So that means some data has labels in it, but some other data it doesn't have any label. It's unlabeled. Okay, it's a combination of both. So as you can see here, this black square means unlabeled data. It has no class value there. But there's some labeled data too. This red data is labeled data. This cross is labeled data, and this star is again labeled data. So this is mixture of labeled data, unlabeled data. So what you're gonna do here in semi-supervised learning is we're gonna improve the performance of supervised learning, the performance of classification learning by utilizing unlabeled data. Okay, if you come here, supervised learning, again, the goal of supervised learning was what? To find a nice best boundary like this. Okay, again, it doesn't necessarily mean this boundary is line. Okay, most likely it's going to be a little complicated boundary curve, whatever. Okay, so anyway, the goal is to find the boundary between these different class values. So in the goal of semi-supervised learning is the goal is the same. You want to find a nice optimal boundary like this. But in this case, semi-supervised learning case, you're going to make use of unlabeled data. Okay, so in semi-supervised learning, by using this unlabeled data, we're going to improve the performance of supervised learning. Okay, so that's the basic idea of a semi-supervised learning. So we don't cover semi-supervised learning, but that doesn't mean this area is not important. This is important, but yeah, we don't cover it because we have a lot of so many algorithms to cover. Okay. This slide is a little replicate of the previous slide. I'm going to explain this supervised, unsupervised, semi-supervised learning by using more examples here. This is an example of label data. Okay, so we have, let's say, we are dealing with the image data. So this is input data. And for each data, input data, you give a label or class value. So in this case, this is a picture of cat. Okay, so this is input data. This is a class value or label. Okay, so every data has its own label or class value. So you have another input data, and we say this class value is dog, label is dog. Okay, so again, in label data, that means every data has its own label or class value. Okay, this is label data. And unlabeled data, on the other hand, is we have input data, but there is no answer, no label, no class value. Because we have input data, like image, whatever, but that's it. Okay, there is no label, no class value, no answer, okay, whatsoever. So you have another input data, but there is no, again, no answer, no label. So this is example of unlabeled data, and this is example of labeled data. So in supervised learnings, we are dealing with label data only. Okay, as you can see here, every data comes with class value or label, right? So a supervised learning, take care of label data only, something like this. In unsupervised learning, it it deals with unlabeled data only, something like this. Okay, so if data is your data has no class value, the only option you have is unsupervised learning. Okay, so unsupervised learning, it deals with input data only, no unlabeled data. Okay, so here this data has no class value here. And finally, semi-supervised learning, then is combination of both. Okay, some data has label, some data is labeled data, and some others are unlabeled data. So semi-supervised learning. So how to improve the supervised learning performance by using unlabeled data. That is the goal of semi-supervised learning. Okay, now let's begin with supervised learning, also known as classification learning. You can consider a supervised learning algorithm as a function which look like this. So here, the F is the classification algorithm. So what it does is it read a certain input X and then it generate a certain output Y. Okay, so in that sense, you can consider classification algorithm F as a function. Okay. So what happened here is I said in supervised learning, every data comes with a class value or a target value, right? Which is output. So in supervised learning, every input comes with output Y. Input X1 comes with output Y1. Y here is target value or class value. So every every input comes with output, okay? So you feed these input-output pairs to this classification function or algorithm. Okay, you keep feeding them. Then this classification algorithm somehow figure out or learn how to map from input data X to output Y. Okay, it learns automatically how to map from input X to output Y. Okay, and this process is called training. So when the training is done, now you give a new data X to function F, okay? Then this classification algorithm F now generate its correct output, okay, Y. So that's what happens in supervised learning or classification. Okay. Again, I'm going to emphasize that this supervised learning algorithm is an implementation of a function. This slide shows some example of classification function. So I said in previous slide, classifier, the classification algorithm is kind of function. So it's we have classifier f, okay, and if you give this image, okay, then this classification algorithm function returns output, returns apple as an output. Okay, so it's like saying this image is apple. Okay, and let's say you give this image as an input, and this classifier gives output saying it's cow. If you give this input, okay, like go image, then this classifier say next move is A7 whatever. Okay, it tells you the next move. This is example of AlphaGo. And let's say you give this image, then this classifier recognize it, and this it says, well, this is digit 3. Okay. So again, you can assume the classification algorithm classifier is kind of a function. Okay. So classification learning actually consists of two phases, two steps: training and testing. So in training, yeah, I told you the supervised learning, classification learning, every data comes with output or target value, right? So in this case, suppose we are dealing with image data, then each image comes with label or a target value. So in this particular case, let's say for this input image, each label is its apple or something like that, okay? So each input comes with label, and you give this pair of input output to the classification function, okay, machine learning model or classification function, whatever you call. You keep feeding them, then this function or machine learning model learns, okay, learns how to map from input data to output label, okay. It automatically learns how to map from input to output, and this process is called training. So in that sense, this classification function is a mapping function between input and output, okay. So when training is done, then when you have new input data like this, then you give this input to this function or machine learning model, which was trained here, okay. Then this function generates its prediction, and this prediction is supposed to be a correct output of this input data, okay. That's the process of testing. So actually, every classifier or classification function belongs to either a linear classifier or nonlinear classifier. And this slide is about a linear classifier, and the next slide is about nonlinear classifier. So I said the classifier is a function, and if you visualize the classification function, you can say the classifier is actually the boundary which separate different class values. Okay, that's a kind of visualization of classifier. So in this case, let's say we have two class values, blue and red. Okay, so the goal of classifier is to find a boundary which separates these two class values. Okay, so Again, a classifier is function, and or in other words, a classifier is a boundary which separate different class values. So when I say linear classifier, then if the boundary is straight line like this, then we say this classifier is linear classifier. Okay. Or if this boundary is not linear, like something very winding or curve, like in next slide, and that classifier is called non-linear classifier. Okay. So the definition of linear classifier is the boundary, okay, which separate different class value is straight line, okay, then the classifier is called linear classifier. So as you can see here, this linear classifier can be represented like this. As you can see, this is linear line. Okay, that's why this is called linear classifier. So every classifier belongs to either linear classifier or non-linear classifier. Okay, but the problem of a linear classifier is this classifier is very easy, very simple. Okay, but problem is in almost every real-world application, these class values are not linearly separable. Okay, the distribution of class values is much more complex than this. Okay, so it's almost impossible, okay, to use linear classifier to separate different class values in real-world application. Okay. So in that sense, the linear classification is very limited in real-world application. Okay. So the previous slide was about the linear classifier, and this slide is about a non-linear classifier. So as I said, if you visualize the classifier, then you can say the classifier is the boundary which separate different class values. So in this particular case, we have a blue class and red class. And if you use linear classifier, no way you can divide this blue class from red class. That's impossible, right? So you definitely need a non-linear classifier, a winding curve like this to separate blue class from red class, right? So that's why we need non-linear classifier. So actually in almost every real-world application, these class distributions are very, very complex, right? So because of that, it's almost impossible to solve a real-world problem by using linear classifier, okay? Real-world problem is much, much more complex than linear problem. That's why almost many classification algorithm is non-linear algorithm, okay? But one advantage of linear classifier is if you are able to solve a problem using a linear classifier, then it is very, very easy to find optimal answer, okay, by using linear classifier, okay? But on the other hand, if you use non-linear classifier, it is very, very difficult to find optimal classifier in non-linear classification. So actually, there are many different classification algorithms to choose from. We have decision trees, we have SVM, we have neural net, and random forest, ADA boost, and K nearest neighbor and deep learning. And we have naive Bayes or GAN, and many more, okay? So we cannot cover all algorithms in this class. So we're gonna cover from decision tree to deep learning here, okay? We don't cover these things. So we're gonna cover these algorithms in this class. Another thing is we have so many classification algorithms, so which one is the best one? So these days people say deep learning is the best classification algorithm. Okay, so we're going to talk about this issue in more detail when we talk about no free lunch theorem. Okay. So we have seen the short introduction of a classification method. Let's move on to another topic, which is clustering algorithms, also known as unsupervised learning. So in this class, we're going to cover the three of them, the k-means and agglomerative clustering and the EM. So we're going to cover these three later in this class as a separate chapters. The goal of clustering is to find the structure of data space. So, but most likely you're going to find the groups of data space which look like this in this. So for example, here we have two groups, and in each group, data in this particular group are supposed to be similar. And again, in this group, all data in this group are supposed to be similar. So again, the goal of clustering is to find these groups.